So you should be on page 11 of your notes. We did skip lesson 3, mainly because lesson 3 is just like lesson 1 and 2, except it has fractions and decimals. And we're just moving on from that. Okay? Page 11, lesson, module 5, lesson 1. So you pretty much got the gist of what we're doing. Okay? So you can do it with the integer chips, which we're going to continue to do, but there's also some rules. And with the rules is a song. And we're going to let Ms. Helms sing the song because y'all do not want to hear me sing the song. Okay? Now, it is to the tune of Row, Row, Row Your Boat. Do you know that song? Row, row, row your boat gently down the stream. Alright, so here's the thing. Listen. Here's the thing. I want to pay attention. Okay? If you can sing one-on-one this first part of the song right here to me or Miss Helms tomorrow, you get your calculator back. You do not get your calculator back until you can sing that top part of the song. Okay? So you have to do it tomorrow. Alright, so we're going to sing it. We're going to get some background music set up, and Miss Helms is going to sing it for you. Alright, are we ready?
Ready.
Listen.
Same sign, add and keep, different signs subtract. Take the sign of the highest number, and you'll be exact. Yes.
Alright, you're going to sing it with in just a second. Ready? Same sign, add and keep, different signs subtract. Take the sign of the highest number, then you'll be exact. Add and keep, different signs subtract.
No.
Take the sign of the highest number, then you'll be exact. One more time. Same sign, add and keep, different signs subtract. Take the sign of the highest number, then you'll be exact. Yay! Alright, so our goal is for that to be stuck in your head. And y'all laugh about it, but my teacher cadet, her mom is a high school math teacher, and they were just singing this song last week as freshmen and sophomores. So if freshmen and sophomores can sing the song, you can sing the song as well. It's very helpful. Okay? So that's what these rules tell us. If they are the same signs, add and keep, meaning if they are both positive or if they're both negative. When we did the integer chips, when both numbers were negative, what was your answer?
Negative.
Negative. When both answers were positive, your answer was positive. That's what these rules are saying. So we're going to build this problem right here. Negative 5 plus negative 4. So build that on your board. Negative 5 plus negative 4. So what color are we starting with?
Red.
Red. Okay? So I should have 1, 2, 3, 4, 5 reds. And then what am I going to do? Negative 5 plus. So that means I'm adding 4 more reds. 2, 3, 4. Alright, and so they're both red because they're both negative. Do I have any pairs to cancel out here? No. So what is your answer?
-9.
Your answer is -9. Same signs, add and keep. This was negative, this was negative. we add the two numbers. 5 plus 4, which gives you 9. Keep the sign. Your sign was negative, so your answer is negative. And that's all you do. Does that make sense? Do we understand that?
Yes.
Okay. So let's look at different signs. That's the second part of the song. Different signs subtract. Take the sign the highest number, then you'll be exact. So if we take and do this, do you see how this is a negative and this is a positive? They're different signs. So according to the song, all we have to do is subtract these two numbers. What's 5 take away 4? 1. Take the sign of the highest number, then you'll be exact. So which is the highest number, 5 or 4? 5. And what is its sign? Negative 1. That's what our answer should be. We're going to prove it with our chips. All right, so build this problem with me. Negative 5 plus 4. Build that problem. What am I starting with?
Red.
How many reds?
5.
I'm going to start with 5 reds. 1, 2, 3, 4, 5. Then what am I going to do?
Add yellow.
Add 4 yellows. Good. 1, 2, 3, 4. Now what can we do? Skylar's already doing it. What are you going to do, Bella?
You take away the same pair.
You can take your pairs away. Pair, 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 pair. And what are you left with? Negative 1. What was our answer supposed to be? Negative 1. Oopsie daisy. Okay. Our answer was negative 1. Okay. So we can use the chips and we can use the song to help us. Alright, so look at number 1 on your note. You probably should have been writing these notes down as we were going along, and I see some empty notes. Alright, number 1, we have a negative and a positive. And I know I haven't given you your homework yet, but that's on purpose. Okay? But I need to see on your homework tonight where you put the signs above the problem. So are these the same or different? Different. So according to the song, if I can say it correctly.
Different signs subtract.
Sorry.
Different signs subtract. Take the sign of the highest number, then you'll be exact.
So are we adding or subtracting these numbers? Different signs subtract. Alright, so are these different signs? Yes. So what are we going to do with the numbers? Subtract 7 and 10. If I have 10, take 7 away. What are you left with? 3. Take the sign of the highest number, then you'll be exact. So which one is the highest number? 10. 10? And what sign does 10 have? Positive. So my answer should be positive 3. Build it with your integer chips to see if that's right. Okay, we're starting with what? We're starting with what? Starting with negative 7. So I should have 7 red chips. 1,
7 red chips.
2, 3, 4, 5, 6, 7. And then what do I need? I need 10 yellows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so then what do I do once I have all my chips? You take the
Take the pairs.
You gotta take the pairs, right? So if I take the pairs, gone. Those are gone. Ah, those are gone. 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 This one's been gone. What are we left with? What are you left with? 3 yellows, which is positive 3. Now look at number 2. Those are really big numbers. So are we going to be able to use our chips on this? No, but you could probably visualize it, right? You can see what's happening. All right, I've got a negative and a negative. Add in. All right, so they're the same sign, so we're going to add the 2 numbers and then keep the sign. So 42 plus 6, 42, 43, 44, 45, 46, 47, 48. Is 48 our final answer?
No.
Negative 48. You got to keep the sign. It might be better to go ahead and drop your sign down, then do your math. All right, number 3. Same or different? Same. So
Same sign.
all right, so add the 2 numbers. 5 plus 2 is 7. Add and keep, so keep the negative. So your answer is negative 7. If you think about it, if I were to build this right here, I would have 5 reds plus 2 more reds. So the only thing I have on my board is red. So my answer is going to be negative. Okay, same thing with the 42 plus the 6. I put 42 red chips out. I put 6 red chips out. The only thing on my board was red, so my answer had to be negative. All right, I want you to try 4, 5, and 6. All right, but let's so that if you choose to use your integer chips, let's make this negative 2. And let's make this just 8. Okay? You do 4, 5, and 6 on your own. So 4, 5, and 6. Use your integer chips and the song. So use both of them. You have until the end of this song to get it figured out. So number 4, we were supposed to change it to -2 plus -5. And what did you get as your answer? -7. Same signs, add and keep. Alright, so listen. Only do the part of what actually applies to the problem, okay? Alright, number 5. 8 plus -13. Were these same or different? I had a positive and I had a negative, so what are they? Same or different? Different signs, subtract. Take the sign of the highest number, then you'll be exact. So what was your answer for number 5? -5 is correct. Good. Alright, and then number 16, you had -15 plus 6. So what did it give you? Who did it? Tinley, what'd you get? -9. Were they the same or different signs? Different. They were different. We had negative and a positive. Different signs, subtract. Alright, so what's 15 minus 6? -9. 15 minus 6 is 9. Take the sign of the highest number, which was 15. So we got -9. Okay? Alright, so how do we feel about that so far? It's easy. Alright, so we're going to keep moving on. Listen. Keep moving on. We're not going to do those 3 for now. Now we're looking at, when we were doing this, we were doing all addition, correct? But we didn't do anything with subtraction, did we? No. Because we don't like to subtract. What we're going to do, this is important, I need you to listen. Anytime you see subtraction, you're going to change it to addition. Okay? So we have this rule of keep, change, change. We keep, change, change. Kind of like your keep, change, flip. Y'all remember keep, change, flip? Yes. Okay. It's similar in that manner, where we're going to keep the first. We're keeping the first integer the same. We're going to change subtraction to addition. And then we're going to change the next integer to its opposite. So what we're going to do is we're going to keep -4, -4. We're going to change subtraction to addition. So we're going to keep -4, change subtraction to addition, and then we're going to change the next number to its opposite. What's the opposite of -3? +3. And then we can work our problem with our integer chips or with the song. Okay, are these the same signs or different? Different signs. Subtract. Take the sign of the highest number, then you'll be exact. So we're going to add or subtract these numbers. Different signs. Subtract. So what's 4 minus 3? 1. Take the sign of the highest number, then you'll be exact. So which number's higher, 4 or 3? 4. So check it with your chips. Build this problem with your chips. -4 plus 3. -4 plus 3. We want to build that problem. Okay, but look, it's -4 plus +3. So this should be. All right, and then when you move your pairs over, I don't know why it's not letting me move my chips over. We cancel those out, and we're left with one red negative chip. Okay? All right, so let's look. I don't know why it's not doing it. So let's look at number. All right, so let's look at number 1. Is the original problem? We're in the middle of recording, guys. Just FYI, which is on YouTube Live. The original problem, 20 minus 30. Because we're minusing, what's the first thing we need to do? Change it to addition. So how do I change it to addition? Keep change. You just wrote it down right above it. Keep, change, change. You should write those letters over that problem. What are we keeping? The 20 stays the same. What's the first thing we change? The minus to a addition. And then what do we change about the 30? Negative 30. And then we could do the problem. Well, we don't have enough chips to do 20 and 30. So that's when we're going to have to know the song. What sign is given to 20? Positive. What sign is given to 30?
Negative.
Are those same or different? Different. So what are we going to do to the numbers? Subtract. What's 30 take away 20? 10. Take the sign of the highest number, then you'll be exact. So 30 is the highest, so what sign should we give it? So our answer should be -10. Alright, for the next one we have -5. Mine's covered up. We have -5 minus 10. What do we have to do first? Keep, change, change. What are we keeping? -5. What are we changing? minus to addition plus, and 10 to, it's positive right now, so it needs to be negative 10. Are their signs the same or are they different? Same sign, add and keep. So 5 plus 10, 15, and keep. So what's the sign going to be? So my answer should be negative 15. Because if you visually built this problem right here, I would be adding 5 red chips and 10 red chips. So I should have 5 and 10, which make 5 and 10 make 15. And because they're all red, my answer would be negative. All right, so negative 20 minus negative 12. You shouldn't have to sharpen your pencil. There's plenty of pencils in the toolbox. So what do we do first? Keep, change. So build the new problem. Write the new expression. What are we keeping? Negative 20. What's the first thing we're changing? Minus to plus. And what else are we changing? Negative to what? Positive 12. Same or different, Pavilion? Your signs, same or different? Different signs. Subtract. So change. What's 20 minus 12, y'all? 8. Take the sign of the highest number, then you'll be exact.
Negative 8.
Negative 8 is your answer. All right, I want you to try 4, 5, and 6. After you change them, if you want to use your chips to build, you can. Okay? They're there if you want them. All right, you've got to get to the end of the song. Do those 3 problems. work here. Lots and lots of good work. Number 4. Sorry, Ghost. Alright, we have to keep, change, change. Some of you had that over your paper and some of us didn't. We have to change 2 things. Some of us were just changing 1 thing. We need to make sure we're changing 2 things. We keep the 10, change subtraction to addition, change -3 to +3. So if you went to build this, you put 10 yellow plus 3 yellow, which gave you 13 yellow, or 13 as a positive. Then y'all look at number 5. Don't overcomplicate number 5. You have 6 and you take 6 away. What's your answer? 0. Now, you could have gone through the whole process of keep, change, change, and that's totally fine. You would have kept it as 6, changed to plus, and then if you built it, you would have had 6 yellows, 6 reds, but they all would have ended up canceling out because this is your additive inverse that we started off talking about. When you add the opposite, your answer is always 0. Okay? So when you have your additive inverse, it's 0. Number 6, we keep, change, change. 5 plus, what else did we change? Jacob? Jacob, what did you change yours to? To +4. Which gave you what, Jacob? Gave you 9. Good job. Okay? Alright. Any questions about those 3? Alright, I want you to try these 3 right here. Try those 3. Try those 3.